just got done flushing our unit, pressurizing the system, burped our pumps. Now we're ready to verify the performance of this unit. We got a two-stage 026 model here, and first thing we always do on our equipment is running it in the cooling mode. It's brand new out of the box. We need to have it in the cooling mode. Again, that's so that if there's any chance of anything in the system, it's going to go through that filter dryer first before hitting that TXV. We're going to take our pressure readings, pressure in, pressure out, and then we're going to convert that to GPM here in a moment over at the book. Then we're also going to take our temperature in, temperature out, our digital pocket thermometer here. So I'm going to start with my pressure gauge, and I'm going to record the readings, and then we'll go over to the specification book and see how we do. These. Do our temperature in. Do our temperature leaving. Record that. We'll gauge out. Now I'll go over here to the workbench where we got our specification book, and we'll see how we do here. We'll first convert our pressure drop to GPM. So we got 27 psi in, 24 out, for a total difference of 3 psi. Now we have to convert that to GPM. We have 81 degrees in. So we go into the book here, entering water temperature, and we can come pretty close with 80 degrees. So that's what we'll use. The next column is GPM. We don't know that just yet. So we'll go to WPD, water pressure drop, and under that 80 degree column, we got 3 options, and we're awfully darn close here to 3.5. So we're going to call it this 3.5. Read over to the left, we got 8 GPM. That's our water flow through that unit, 8 GPM. So we'll record here in our water side performance sheet. GPM we put in the middle here. We're going to put down 8. Next we'll put our delta T. We had 81 degrees in, 89 degrees out. So we call that, again, that'll be 8 degrees difference, 8 degree delta T. And then our fluid factor, 1 of 2 fluid factor numbers. We use either 500 for water or 485 for antifreeze. But remember, we put methanol in this loop, so we got 485. I'll now multiply this out. So we got 8 times 8 times 485. Comes up to 31,040 BTUs. That's our actual calculated heat of rejection out of this unit. We'll now go here to the specifications, and we'll look under 80 degree, 8 GPM, 850 CFM is what our airflow is. We'll come across here to the HR column, follow it down, and our specification is 32,100 BTUs. 32,100 BTUs. And as you can see, we're well within our 10% limit there on that. We're within that 10% of that number. So this unit is running just fine. There'd be no need to do any further troubleshooting. We're going to talk about bumping the loop pressure up. And in order to do that, we can simply do that with what we call bump up tool. This little tool here with a PT needle, basically a boiler drain. And what we need to first do is hook our garden hose to a cold water source. Not that hot water tank that's close to the unit typically, because again, we want to use cold water, and we must bleed that hose before we hook the tool to it. So we've added this little adapter here on the end so that we could turn it on and off. we're going to go ahead and bleed this, and again, like anything else, you got to get 2 feet per second in order to get all the air out of this. So we don't want to be putting air into our loop when we're trying to bump that pressure up. So I'm going to go ahead and bleed the hose. Once I feel I've got that bled, I can now hook my tool to this, and then all I have to do is bleed what little bit is in this, the volume of this tool. So I'll tighten this up. I've got the valve shut off to the tool right now, so I'll turn this my additional little valve on here, and now I'll bleed through the PT needle here. And I'll let that bleed for a few seconds, just to be sure I've got that bled. Once I'm comfortable I do, I'll throttle it down, but I do not shut it clear off. Reason being is if I do, I could have the water come out of this tool, and then I'm going to be putting air into the loop. So I'm simply hold my finger over it, insert it into the PT port. Now, it's very important when we do this that we have our control door here shut, because any water splattering on those electronic boards are going to cause us all kinds of problems. Now on the opposite port we've got our pressure gauge installed. Now we'll simply open our valve up and watch our pressure climb. And again, depending upon what your household pressure is set at, we should about easily obtain between 40 and 50 psi. Good operating range here for our closed loop system. So if I can get 50 psi, I'll go ahead and bump it up to 50. We'll see what kind of pressure we've got here from our municipal source. You see we're slowly climbing up. Now we're not adding a whole lot of water into the system. Some people fear that you're diluting the system so much, but again, water is non-compressible. So we're not adding a whole lot to this. So once it hits 50 here, I'll go ahead and kill it. Shut the tool off. As you can see, we're right there about 50 psi. We've now bumped that pressure up. We were down in the 15 psi range, which again, as long as we got positive pressure on the system, according to Grundfos, as long as we got 3 psi on the return side of the pump, we do not have a problem with the system. So again, that's how you simply can bump up the loop pressure in your closed loop pressurized system. And now I'll remove the tool. And I'll shut this valve off, and I'm going to remove the tool. From the hose. Another use of this bump up tool is actually we can get a sample of what's in the loop here, what's in the system. If we go out on a call and we keep falling out on FP1, our freeze protection, and the jumper's not been cut, we think there's antifreeze in the system, we can draw a sample of this without having our flush card on here. So how we can simply do that is close the valve off. We can insert that into usually the upper PT port, so we got some room to work below this tool. Put a pressure gauge in the opposite port. So again, we want to make sure as we're drawing the sample, we never draw this down below 0. So now I can put, again, all I need is basically a styrofoam coffee cup here to get a sample solution. I don't need a whole lot. I'll now crack this open. Draw this solution. As you can see, my pressure is going down slowly. Now I've got a sample solution here, and you can see we were up about 45 psi, and we dropped about 10 psi here to get the same amount of solution out that we took out of the flush card earlier. Now again, we can drop this simply in our test tube like we did earlier out of the flush cart, and then float our hydrometer in it. You can see now we have enough solution in here to actually float our hydrometer in there, and then see what our freeze protection is. And if we got 15 degrees freeze protection, then we can cut that FP1 jumper and get this homeowner out of having this unit trip out.